Hello and welcome to this presentation, which we hope will give you some insight into the design considerations behind the information model implemented in the WRAM 2 data warehouse. WRAM 1 is a working system but was designed for a limited scale and has now outgrown this design. Ad hoc development has produced quite a complex system of largely independent databases. Even small changes are now very demanding in respect of development time and administration. WRAM 1 offers spatial support, but this is limited to points. One of WRAM 2's biggest aims is to be essentially generic. This will make it both suitable and practical for as many new remote animal monitoring projects as possible, but also for the projects currently hosted in WRAM 1. WRAM 2 should have quick startup times and be light on administration when adding new projects, sensors, measurement types and so forth. Experience says we can expect continued massive growth of measurement data, and WRAM 2 needs to be performance conscious in light of that. WRAM 2 will extend spatial support to include lines and will address issues such as out-of-sequence data delivery. The information model's basic hierarchy is an abstraction of a typical project. Projects containing animals wearing tags which may have multiple sensors. The project animal tag sensor relationship is central to the design. WRAM 2 will be suitable for all remote animal monitoring projects which match this pattern. Common practices seen in remote animal monitoring projects need to be addressed by the model. Mapping tables are used to extend the basic hierarchy in order to cater for these issues. Some examples: single or multiple tags, multiple sensors. Equipment may be added, removed or replaced. Deployment can be periodic. Equipment may be in or out of service. Equipment can be reused on different animals or indeed in other projects. Projects have lifespans. These can begin and end and are sometimes superseded. Animals can be transferred into other projects. In some cases, animals may be participating in multiple projects, as can be seen here with fish number 6. Of course, storing measurement data is central to our model design. To afford the scalability we desire, we've chosen to store data in serialized measurement tables. Numeric, text and date tables will store all measurement data across all hosted projects. Serialization means moving from shorter tables with many columns to narrow tables with many rows. In the example, a GPS data record with many columns has its numeric measurements transferred to individual rows in the numeric serial measurement table. This design means new measurement types can be added easily without the overhead of constant table design changes. To put this into context, we can take a very real example. WRAM 1 has currently about 20 million GPS records. That's 20 million rows in a 35-column table. In the WRAM 2 serialized table, that would be 700 million rows. Serialization does have a small effect on performance, but this is offset by optimized indexing and by SQL Server 12's support for row-based partitioning, which we use to provide each serial measurement type with its own partition. WRAM 2 stores spatial points and spatial lines. All points are stored in the WGS84 format, but also in the native imported format if that is different. Points are also stored in the 3857 format, particularly for Google and Bing Maps. The intention here is to reduce visualization response times by not requiring a transformation at query time. There's also support to store points in a locally preferred format if required, such as Sweden's RT90. Lines are created over time from point data, with maintenance routines in place for periodic and out-of-sequence data delivery. We use the open source OGR to OGR tool for transformations between OGC recognized formats, and we never perform more than a single transformation from the native format. The information model has been designed with much thought towards expansion, clarity, and manageability. Administration is minimalized when adding new projects, animals, tags, and sensors, thanks to the extended hierarchy. The serialization of measurement tables means that new sensor readings and data types can be easily supported, and again, with a minimum of administration. Security and access are important concerns for data owners uploading their data into WRAM. Because data from all projects share common tables, we've implemented row-level security. This is combined with view and field granularity, such as specific tag numbers and date ranges. Together, this provides data owners full flexibility in granting and restricting user access to their data. Although not yet implemented, data owners will be able to manage security via the WRAM portal. The model implements a traditional security structure of users and groups. The user perspective is key during the design process, and user feedback gained through conferences such as this one is much appreciated. WRAM focuses on 4 major user groups and their anticipated usage patterns, which however are in no way limiting. Researchers are mostly expected to be interested in historic data as opposed to real time, with a focus on trend analysis. Data quality and sound metadata are important. Members of the public will have a more random nature with their data requests, where local data may be of interest. Wildlife managers are expected to have a higher interest in current real-time data. Data owners will be concerned with security, accessibility, and availability of their data, and will require a user-friendly interface with the system. So, let's recap this part of the presentation. Aware of the limitations of the WRAM1 system, and with attention to both expected storage and usage scenarios, the WRAM2 model has been designed with an emphasis on being generic, manageable, and sustainable. Object orientation and serialization facilitate adding new objects and new measurements easily, while keeping administration overhead to a minimum. Spatial support has been extended to provide spatial points and spatial lines. The system implements a security which is both robust and versatile, and which will be comfortably managed by respective data owners. Thank you for listening.